Hello, everyone. Yeah, welcome to another lecture series on indices and logarithm. In today's study, we will be discussing the assignment I left you in the previous session. I recorded some for you during the meeting, and the other ones I left on the school page. So for now, I'm going to discuss what I gave you during the lecture session. I still haven't received your assignment for what I gave you on the page, so it wouldn't be wise to solve that with you here. I expect you to put that to work, apply it, and let me see your strength and weakness. Before we can do that in general, then we can move to the next thing we have to do. All right, so you dictate the question to me, and then we'll look at that. First of all, how many were there? Make sure we are solving everything. How many questions were those?
Oh, that means there were three.
Okay, so you call them out for me. Dennis, are you sure you're on the meeting or yeah, just you join and the phone is somewhere? Call it out.
Okay, so the A is 32 exponent 2 over 5.
Mm-hmm.
And then number 2 is 100
What that was it.
exponent
This is just the question.
1.
This is just the question.
Yes, this
Okay.
was,
Okay, the next one.
yes, just the question.
Okay.
100 exponents 1.5.
Okay. Then the next one.
No, there's a 1. No, the 100, there is a 1 whole number before the half.
All right. So 100 exponents, one whole number, number two. 1 second.
Yes, 1 over
One whole number, 1/2. What's the next one?
2.
I think Dennis is trying to talk or not her. All right. The next one. Yeah.
That means the next one.
Yeah. The next question.
8 over 7.
8/7.
That means 8 over 27. All over negative 2 over m. All over exponent negative 2 over 3.
No, it's not adding up.
No, no. That's a wrong question.
Do you mean this? Are these part of the assignment I gave you? Look, fix that and then let me know. When you see the assignment,
No,
let me
come
know.
on. Okay, so if 2 exponents negative n,
Oh, really? No
yes.
one did all of these things. Go on.
Okay, maybe I didn't join the class, I think last week, so maybe the questions were changed.
No, I remember giving a question like this, I've not received solutions for.
Okay, if 2 exponents negative n is equal to x,
Go on.
find 2 exponents n.
Is that all?
Yes, please. This was the first day you give us during the meeting.
And I didn't see anyone tackling, especially the third one. Then
So it
who
was
is the expert
confusing.
for all these sessions? So let me see. Let me review the solution side. Oh, okay. I saw you writing that. 2x with a negative n, right? Not n.
Yes, negative n.
Okay.
Yes.
Go through the solution and figure this out. The one is and then there is an Ivan. I think your Ivan, which involved the X, were the ones I dropped on the paper. Anyway,
Yeah.
I didn't see anyone doing any of these. The last one especially. Hmm? I'm not comfortable coming here to solve the questions. I write the question and solve for you. I'm not testing myself. You should do it, then you identify where your problem is. I solve it for you. I make things easier for you. That's why when I come, I just end the meeting because it appears many of you are not serious about this. So if you are not serious for a session, why should I waste my precious time when I can be out there doing something different that will fetch me money?
Sorry, sir. Last chance.
I'm going to try that with you.
Okay, sir.
Yeah, so the first one, 32 exponent. With this, I think many of you could do that. 32
Yes, I think that
exponent.
was
Yeah,
correct for
yeah,
me.
2 over 5, yeah. So I think last time I told you there is a relationship between fractional index and root of numbers, right? So
Yes,
this one is equal to fifth root, fifth root of, fifth root of, I don't know if, 1 second. Yeah, so fifth root
32.
of 32 exponent what? 2.
Hmm.
Yeah, yeah, I'm sorry, I got distracted by a test. Fifth root of 32 exponent 2. Okay, right. So that is it. Now, I want to say this again. I say a lot of things, and you have to pay attention to what I say more than what I write for you. There is a topic in mathematics called sets. Under this topic, we'll be using a lot of root of numbers, okay?
Okay,
And
sir.
you get to see things like 5 root, let's say 25. 5 root 25 is the same as 5 times root 25, okay? Yeah.
Okay.
But you get to see something like 5 root 25. You see, a thing like this exists. And I just told you it means 5 times root 25. So, and you also learned that there are different kinds of roots, right? We
Yes,
have the
sir.
second root, square root, right? Which we don't write. So under sets, the kind of root we use often is the square root. Under sets, we use the square root a lot. So you see square root all through and through. Now, now you have come to learn that there are different kinds of roots, right? So we can have fifth root. So I brought this up to let you know that when you are writing your fifth root, write it well. Let it be small, represented this way. Okay, so it doesn't, we do not
Look
translate
like a
as
bed.
5 root 25. It's two different things.
Okay.
5 root
Okay, sir.
25 is the same as it's the same as 5 times root 25. The answer is different too.
Okay.
Like take your calculator and punch 5 root 25. It's going to give you 25. The answer is different from fifth root of 25. The answer is different from fifth root of 25. You don't just punch 5, then you punch square root on your calculator. That's not how it's done. When you go to your calculator, last time I told you, on your calculator, you see this key, X index, a box. You see this key. Now, on top of this key, you will see this key, right? You see this key. It's written in yellow. Okay. So now to get to this feature, press shift, then you come and press this key. Look for shift, press it and come and press this key. You get this. So this is what we use for fit root of 25. And fit root of 25 is not plausible. It will give you mass error. So I'm just telling you this so that you write it properly. Yeah, you write it properly. Can I go on? Okay.
Yes, sir.
Yes, sir.
Okay. So now, and don't be happy I'm solving this for you because tomorrow it will not happen. Today is because I'm in a good mood. It's my birthday. That's why I'm being generous.
Oh, happy
And as
birthday.
tomorrow, if I give you work and you don't do it,
Happy birthday,
I'll just end the meeting
sir.
Happy
with you.
birthday.
Anyways, let's continue.
You didn't tell
So,
anyone. Hey.
yeah, I mean, birthdays are
Like
well
we'll come and
celebrated
surprise you
when,
where you are.
oh, birthdays are well appreciated when you keep it private, That's when you get to know those that truly cares. Yeah. Anyway, so can you check for me 32 index 2? 32 index 2. I think I have a calculator here. That will give you 1024. Now, I've not tried the other way, okay, but situations like this, please solve the one inside the root first. So 32 index 2, find a solution. When you are done, then you can now find the fit root of 1024. And you see something like this, fit root of 1024, you have to learn how to use a calculator. Let me know if someone has a question on the how I was showing you to punch the fit roots from your calculator. If you don't, you should be able to put it on your calculator. Fit root of 1024. What are you getting? It's 4. And that's the answer. Hi guys, can I continue?
Yes, sir.
All right. The next one. Now, this I saw some people getting it wrong, and I will see. 100 exponent, one whole number, 1 over 2. Now, you got this wrong because number one, you don't know about how to re-express mixed fraction. And even if you don't know how to express this, it was on your calculator. You could have punched it easily on a calculator, but you didn't know how to do that. So I'm going to show you the two ways. Let's start with the calculator. If you want to punch one whole number, 1 over 2, I don't know. My hair is unkept, so I can't turn my video. I would have shown you from the calculator, but listen to me. I have one here. I have a calculator here, so I'll show you where to press and you follow along. If you have one though. If you don't have one, you can download these scientific calculators on your calculators. It works similar to this. Yeah. Now, one whole number, 1 over 2. You don't punch this on a calculator as you press 1 first. I think many of you were pressing 1, then after you press 1 over 2. No. If you do it like this, the calculator assume it as 1 times 1 over 2. It's different. The answer for this is different from one whole number, 1 over 2. If you want to punch it properly on the calculator, look for this key. I'm coming. Look for this key on your calculator. This key. It comes this way, box over box. There is a key like this on your calculator. Now, if you find this key, on top of this key, you see a box on the edge, then box over box. If you find this, you find this. This one is on top of this. Okay. And to get this, just press shift, then you get it. Immediately you press shift and you press this key, you will get this. So when you get this, now put your one here. You can your cursor will be blinking here, so you put your one there. Then you use the cursor. I believe you know your cursor control keys. You shift the arrow, make sure it comes here. Then you punch 1 over there. You shift it down, then you punch 2 at the bottom. If you do it that way, it will give you an answer, which is what? 3/2
So
or
3/2.
something. Yeah, and that's the answer. It's different from doing 1, then you multiply it to 1/2. This it will give you 1/2. But the answer is 3/2. So let me show you how to do that. So the solution to this will become 100 exponent what? 3/2. Now let me show you how we actually landed on that. In case you do not have a calculator by you. Yeah, 3/2. So this is how it works. So this is called a mixed fraction. Whenever mixed fractions are numbers represented like this, a whole number, something, something, whole number, this over that, something, something, whole number, this over that. When you have a mixed fraction, this is how you solve. Use the denominator to multiply the whole number portion. So that would be 2 times 1, which is what? 3.
2
Okay.
times 1. 2.
Yeah, you use the denominator to multiply the whole number part. So 2 times 1 is what? 2. Sorry.
2.
Then the result you get after multiplying, you add it to the numerator. So 2 times 1 is 2 plus 1 will be what? 3. So the answer is 3/2. I can give you 4 whole number 1/7. To solve this, use the denominator to multiply the numerator. Sorry, to multiply the whole number part. So 7 times 4 is
28.
28. Then you add it to the numerator, which is so 28 plus 1. So that'll be 29/7. This is how we do with mixed fractions. This is how we re-express mixed fractions. So now, having re-expressed this one, you have 100 exponent what? 3/2. I believe you can solve this, right? Fractional index, you just take what? The square root. So the denominator will name the root. And I just told you square roots are better written without a 2. All right. So square root of what? 100.
Okay.
Index 3. Then now I said look for 100 index what? 3, which is 1 with, I don't know how many zeros that will be if it's 4 or 5.
1,000. 4,000.
I think it's more than that. Oh, let me see. Yeah, you're right, 1,000. So then now you find the square root of what that? Is it 10 or 100?
1,000.
I think
So
what?
it's 10. It's
It's
10.
10 roots 10.
Yes.
Okay, that's fine. So that is it.
Okay. Okay.
Now let me know if we are on the same page before we can move on. So you see, this one is 10 root 10, not 10th root of 10. So you write it well. Okay, 10 root 10. Maybe you are wondering, so say, what if there is no calculator? How will I code this to get 10 root 10? When we are treating search, you learn all these techniques. Can we move on? Can we move on? Yeah. Let me know if you're on the same page so we can look at the last one. Now, do all these corrections in your book.
Okay.
I'll wait when you're ready, we continue. Right, so there was this problem which says if 2 exponent negative n equals x, we are to find 2 exponent n. Then, so we said that in our previous session, we said 2 exponent negative n, any number raised to a negative index is equal to the reciprocal of the number. So that'll be 1/2. 1/2. Why 1/2? The reciprocal of the number. The number here is 2, and 2, any whole number is believed to be over 1. So if you are to turn it upside down, reciprocate it, you have 1/2. Okay, so we said any number raised to a negative index is equal to the reciprocal of that number raised to the same but positive index. Yeah, raised to the same but so all of this raised to the same index, but it should be positive. That's why it's no longer negative n. And one of the rules we learned about the when you have the power of quotient of two numbers, what happens is that the power affects each thing in a fraction, in a bracket. So that'll be one exponent n, which is 1/2 exponent what n. One exponent n is 1. So you have 1/2n. So if you come back to the solution, that's what you see 1/2n. Okay, for this one equals x. Then I was telling them that when you have a fraction equated or equals a whole number, or a fraction equals a fraction. A fraction equals a fraction. A fraction equals a whole number, or even a whole number equals fraction. Just cross multiply. That is it. That's a way to solve. Cross multiply. So we re-express the x over 1, and then we cross multiply. So we add 1 times 1, which is 1 here. The equal sign, 2 exponent n times x is 2 exponent nx. Okay. And the question said find 2 exponent n. Yeah, so we made 2 exponent in the subject by dividing by the x, which is attached to it. Cancel out. Mass, whatever you do on the left-hand side, you do the same thing on the right-hand side. So at the end of the day, you have 2 exponent n equals 1/x, and that's the answer. All right. Now, I'm done with the first 3 questions I gave you, and I believe you've seen where your problems are. Now you can take me back to the assignment, the main assignment I gave you. If you have any questions on that, let me know and I can address that. Either than that, I will start a lecture, which I don't think is the best.
Okay.
Mm.
So can we solve the rest or
Let me know the ones you tackled but had issues.
okay,
Yeah.
so I start with the 4, the 5, and the 6. I don't know about the rest, so
Yeah, you can bring them up. I'm flipping up.
okay.
Okay, so you can call out the question.
Okay, so the 4, x exponent
X exponent 2. Mhm.
b, yeah,
B for boy.
over, yes, b for boy,
Mhm.
x exponent c, they are into brackets, so x exponent c,
Hold on, let me check something. This question, I addressed that in our previous lecture. I sort of recorded that.
yeah, I think
So
when
let me
they,
do it. Let me do it because I can't merge the two recordings. So let me do it again.
okay, so
Over x exponent c.
c, yes,
Mhm.
brackets, there's a brackets, all exponents a.
A, okay.
Yeah. And then x exponent c
Mhm.
over x exponent a,
Mhm.
brackets close, all exponents b,
Mhm.
times
Okay. I think I've opened it
x
here.
exponent a,
All over x exponent b exponent
yes,
c.
brackets close, c, yeah.
So while you all may have your own solutions to that, as long as I reviewed that and told you it's correct, it's correct. If it's wrong, if I told you it's wrong, it's wrong.
But I didn't get a mark for that.
Okay, let's see. Maybe your final answer was a problem. So here, first, let's do with the index. I only have a power of quotient of two numbers. I said the index affect the numerator, it affect the denominator as well. So this will become x exponent BA, right?
Okay.
The x exponent C will also be affected to be CA
Yeah.
times. This one will be x exponent CB all
B,
over x exponent AB.
B,
Yeah, or yeah,
B.
AB will be a whatever. Yeah. Then this one will be x exponent AC. In algebra, I like going with alphabetical order. So I've made some mistakes, but it doesn't matter. If you want to do everything professionally, you can stick to what I told you, alphabetically order. All right, x exponent what? BC. Then now, if you are applying the laws of indices, when you have two numbers dividing each other and the bases are the same, you pick one base, you subtract the power, so that'll be what? BA minus what? CA. Do you agree with me?
Yes,
Okay.
yes, sir.
Times, so this one will also be CB minus AB times, if you're applying the same thing, times x exponent AC minus what? BC. Okay. Now, at the end of the day, you see, forget about the tuple. I'm looking at the down. The bases are all the same and they are multiplying. So I'm just going to pick one. I think it looks easier doing this. I'll just pick one. We are all the same. I'll pick one. We are multiplying, so I'll add everything at the top. The top will be BA minus what? CA plus
Uh,
CB
CB.
minus AB. Please, if it's minus, introduce bracket, okay? Go
Okay.
minus if you don't take care. If it's minus, it will happen. Something will happen if you are expanding the bracket. So if it's minus, introduce the bracket, else you'll be wrong. I think I saw someone committing an error like that along the line. Anyway, then plus AC minus BC. So that'll be x exponent. Now, let's see. BA minus AB. ABBA is the same thing, right? So that'll be 0. So I've canceled it off. Minus CA plus CA. You see, that's nothing. AC, nothing, right? CB, like CB minus CB, right? It's the same thing. So it's 0. So the top is 0. Do you agree? And if it is 0, any number raised to an index of 0 is 1. There's the answer. You can check if you had that. Hey, a lot of people are having network challenges. So, yeah. They join, they leave, they join, they leave. Yeah. Okay. You may let me know the other example you were doing that you found challenging. If you're writing to, I'm going to pause.
The x exponent b.
1 second. I believe you did this. You tried that.
Yes, so I tried the four that we just solved, but then you didn't give me a mark for that.
No, I marked that way emoji. So go and check. If it was correct, I said correct. If it was wrong, I use times. You look at my reactions.
Okay. It was
Yeah.
correct.
If it was
Yes,
correct,
so
I
the
use
five and the
correct.
six, the five and the six was what I got wrong.
Exactly. Now,
Okay.
if any of them require some questioning, I questioned you. Okay, so you can call it out.
Okay, so the five,
Um, okay,
x exponent b, bracket open. So x exponent b
okay.
over x exponent c,
1 second. X exponent C.
b bracket close,
Mhm.
exponent 1 over bc
Okay.
times
Mm-hmm.
bracket open x exponent c over x exponent a,
Mm-hmm.
bracket close, exponent 1 over ca.
Okay.
Yeah. Times x exponent a
Mm-hmm.
over x exponent b,
Mm-hmm.
bracket close, exponent 1 over ab.
Right. So let's look at it. One second. Right. I'm sorry. I had to attend to a messy problem. So, um, yeah, so I guess we apply the same thing, right? We have a power of quotient of two numbers. So for the first bracket, we have an x exponent b times 1 over bc, right? All
Yeah.
over x exponent c times 1 over bc times, oh, no need, times x exponent c times 1 over c all over x exponent a times 1 over c times x exponent a times 1 over ab all over x exponent b times 1 over ab. But I see some stuff can cancel. This, that, that, this, that, right? This, that, this, that, this, that, this, that. And I'm having x exponent 1 over c. This is so easy. All over x exponent 1 over b.
1/b.
Can't really tell where you had wrong, but we
Okay,
just
so
follow.
instead of the 1/c, I just did it s exponent c over s exponent b.
Yeah, so I guess that was it.
Yeah.
Yeah, this one will be x exponent 1 over a
Yeah.
on x exponent 1 over c times x exponent 1 over b
1/b.
all over x exponent 1
1/a.
over a. Yeah. Then now, the b's are the same. So I'll pick one. I'll subtract the powers 1 over c minus 1 over b times x. I'll subtract the powers 1 over a minus 1 over c times, yeah, I'll subtract the powers. That's is 1 over b minus 1 over a. Then now, the b's are the same again, right? And they are
Yeah.
multiplying. So I'll just pick one. And if they are multiplying, add the powers. So that'll be 1 over b minus 1 over, I said 1 over b, but I ended up writing the right one. All right. So 1 over c
Plus
minus 1 over b, yeah, plus 1 over
1/a.
a minus, oops, yeah, plus 1 over b minus 1 over what, c. Then let's see. Oh, 1 over c, 1 over c, gone. Minus 1 over b plus 1 over b, gone. 1 over
Okay.
a, oh, I don't have to cancel. Good. I think that is it all. So we have So we have x exponent 1 over a minus 1 over what? C, which I can solve further. You can leave your answer this way, or you can choose to find the LCM,
I
which
say, wait.
yeah, the LCM will be what? AC. A into, usually that's how we find LCM in algebra when the b's are letters variables. You just join all of them. You can write all of them, join them together. So now when A comes here, it cancels the A, it goes into a C times C times the numerator. Numerator is what? C minus C into this is A times the numerator, A times 1 is A. Was this even necessary? Yeah, that's the answer. X exponent 1 over X
Let's
exponent
go
C.
back. There's a confusion somewhere.
Okay, okay. What part?
So after the
Do you
third
see it
step,
clearly on your phone when I zoom like that?
yes, I can
Yes,
see
sir.
it clearly.
Okay, so what part?
Can't remember it.
So line one, line
Yes,
two,
so
line three.
where we were adding,
I'm coming.
there's two rooms.
Okay,
It's actually the last but two steps, I think.
okay, I'm coming. Last but two. The addition when I was canceling.
Yes.
Oh, I'm just saying that you see anything minus if you subtracting ama from ama is nothing. So I don't
Yeah,
need to.
no, the last one is supposed to be plus 1 over B minus 1 over A. It goes 1 over C.
Mm, x exponent what? 1 over what?
B, that's the last one. 1 over B
Mm-hmm.
minus 1 over A. But then you wrote 1 over C.
No, I'm coming. This 1 over c, right? Let me use black. 1 over c is this, right? It cancels 1 over c here. 1 over c minus the
Yeah,
sign is
yes, sir. That's where the confusion is.
so you see.
From the step before that.
Okay, let me see that one too. 1 over c
So
minus 1 over b plus 1 over a minus 1 over
A
c plus 1
plus
over b.
1 over B
Oh,
minus,
minus
it's
1
supposed to
over,
be 1
here is
over
1
A.
over a. Okay.
Yes.
Um, Let me see if I 1 over a. Okay. Okay. So if that is the case, let's do it again. Um,
Okay, sir.
1 over c will cancel 1 over c minus 0.
Okay.
1 over a will also cancel 1 over a, 0.
Yes.
Then 1 over b, oh, then everything is 0.
Yes.
I think it was intentional. Hmm, okay. Yeah, that'll be x exponent 0, which is what? 1. Yeah, so all these lengthy stuff actually resolve to 1. Hmm. I'm trying to zoom for you, but 1 second. Let's see. Keep going. Okay. I want you to see everything. Does it look well on your phone? Oops, I spelled it. Keep going.
That's true. Tiny.
Yeah, I'm coming. I'm still
Okay.
zooming. Oh, come on. I'm coming. Oh, why? Oh, guys, I'm coming. Does this look okay?
So this is okay.
Okay. I want you to see everything well. Yeah. Oh, I have to pause this. Okay, so this another question I would like us to look at. Okay, let me zoom. Good. Yeah. Okay, so let me see. Mm, so this is quite easy.
Yeah.
You can
Still have it wrong.
re-express it or you go straight to the point. But I don't know if you guys will agree with me on what I'm coming to do. I'll just pick X. The B's are the same, so I don't know if you guys will agree with me that I just take X and then subtract the top. So 2b. Do you remember what I told you about subtraction? I said when it's about subtraction, introduce a
Opening the
bracket. Do you
bracket.
remember? Good.
Yeah.
Yeah. 2a minus 2b. I have a feeling, Abby, you tried this and I gave you wrong.
Yes, sir,
And
yes.
and this is the reason, the subtraction. You introduce a bracket because having introduced a bracket, something is going to change right now during expansion. And you see that area you maintain minus, but it should be something like plus. We'll come to that. Then
Okay, sir.
y, the base are the same. So y to be 2 minus. Remember, if the number is standing there without an index, is power 1. Yeah. So x. So it was just a few issues with your algebra, which I think I'm retraining you so you get better. Yeah.
Yes,
So
sir.
here will be 3a minus 2b. Now expand. That'll be minus what? 2a. When minus meets minus, it's plus.
I did it.
So plus 2b. And if you check yours, you wrote minus. Some of you might have done the same thing.
So I
But
wrote exactly what you've written.
you wrote plus.
Yeah, so it was I wrote 3a minus 2b minus
Mhm.
2a plus 2b. It's exactly the same thing.
Then I don't
Mm.
know where the problem was. So let's see. Anyway, why? So 2 minus 1 is 1. I choose not to write it. If you did so, let's see. I don't know. So 3a has to know. Okay, there is an a here minus 2a. So
So
3a
that's a.
minus 2a is 1a or a.
Yeah,
Then minus 2b plus 2b is 0.
yeah.
So that'll be a plus 0, which is a. So x exponent a1.
AY.
Did you get
Yes.
this?
Yes, so you gave me
Oh,
wrong.
why? I'm coming. I'll check. Why did I score you wrongly? I'm coming. 1 second. Oh, I'm looking for the question. Mm. Oh, if I did, then I'm sorry. I can't even trace that. Mm. Okay. I can't trace the question from your work, but I mean, if I did score you wrongly, I'm sorry about that.
Yeah.
Okay, so this is another question. Okay, you highlighted it. Oh, and I said wrong. How?
Mm.
Oh, three. Maybe my mind was hot at that time. Uh, oh, you are right. Let me change it. Okay, to correct. All right. Yeah, any other person? All right. If there is any other question, you can let me know. Oh, next question. Yeah, next
Good.
question.
Bracket open. 3 exponents negative 1
3 exponent negative 1. Mm-hmm.
times 7 exponent 2
Mm-hmm.
over 3 exponents 3
Okay.
times 7 exponents negative 4. They are
Okay.
all age brackets.
Okay.
Yes. Exponent 7 over 2.
Okay.
Yes. Divided by
Mm-hmm.
3 exponents 3
Mm-hmm.
times 7 exponents negative 5.
This was just numbers.
2 exponents negative 2
Mm-hmm.
times 7 exponents 3. Bracket close. All exponents negative 5 over 2.
This was just numbers when we say it was confusing. Just
So
apply what I
just
told
have
you.
to rectificate something. I tried it.
Okay, so let's see. This was easy. I'll just apply what we know. That when you have a power of quotient of two numbers, when you have a power of quotient of 2 now, when I have a power outside the bracket, the power will affect every single thing in the bracket. That's what I know. So I'll deal with that. So you, 3 exponent negative 1, you'll be affected by the power. You get it?
Yeah.
So let's see. Yeah, it will be affected by the power. When we are done, you can even confirm from your calculator. 7 exponent 2 will be affected by it. Yeah, I'll need space. So. Yeah, 3 exponent 3 will be affected by it. There are different ways to deal with this, okay, but for the purpose of tuition, I just want to you open up like this for you to understand. So this 1 to 3 exponent 3 times minus 5 over 2 times 7 exponent minus 5 times minus 5 over 2 all over 2 exponent minus 2 times minus 5 over 2 times 7 exponent what? 3 times minus 5 over 2. Let's try and do this. All right. So let's see. So this one becomes 3 exponent 7 over 2, right?
Yeah,
Yeah.
minus 7.
Times 7 exponent 14 over 2. Why don't we jump into conclusion? 14 over 2 is what? 7.
7.
Yeah. Well, the 2 even cancels that. You know,
So that 3 exponent 7 over 2, there's a negative sign. No?
oh, minus 7 over 2 then. Yeah. Thank you. The base 2 will be 3 exponent 21 over 2 times 7 exponent. This one will get into this 2 times, right? So minus 2 times 7, minus 14, right? Divided by 3 exponent minus 15 over 2 times 7 exponent minus, no, I'm coming now. Positive will be, what should I do? Let me clean this. Yeah, good. So yeah, what's that? Minus 5 minus 5. That would be positive 25. Yeah, over 2. Yeah, on 2 exponent. This one cancels that. Minus 1 times minus 5 will be positive 5.
Okay.
No need to stress your head. Just put them on your calculator and you're good to go. 7 exponent minus 15 over 2. Then we do what we were doing in the previous example. I'll take the 3 top, 3 down. So 3, then I subtract them. They are dividing. So 7 over 2 minus what? 21 over 2, right? Then
Yeah.
times 7 exponent or 7 minus 4.
14.
14. If you observe and you see that it will be plus 14.
Okay.
Let's do minus minus. Everyone to understand. Yeah. Then divided by yeah. Oh, the base was really 2. Is everything okay with the question before I waste my time? Okay, let's just say it's okay. All right, so 1 second. I'm just looking for a way. The bees are not the same, so
The bills are not the same.
so you know what? Let's come. So let's just do this. 3 exponent negative 15 over 2 on 2 exponent 5. Yeah.
times. We
times
have the same
7
thing.
exponent 25 over 2 minus
Minus.
15 over 2. Right.
Yeah.
What have I done? Is it 7? What? Times. They don't appear well. 1 second. It should be times. Okay. Times, yeah, 7. It should be 7. No. Yeah. Now, I want us to use the calculator. Okay. Just do it on the calculator. 3. Check the top for me. This one, don't want to waste time. Minus 7 over 2, right? Minus 21 over 2. That's minus 14. Want to be sure we're on the same page.
Minus 14, yeah.
All right. Then it's minus 14 times. So this one will be what? 7.
Yeah, 21. Exponent 21.
Okay. Then divided by let's maintain this. 3
Okay,
is
so
for the negative 15 on 2. It doesn't look like an index. 1 second. Negative 15 on 2 all over 2 exponent 5 times, yeah. So how about this? 25 over 2 plus 15 over 2. That'll be 20. Are we on the same page? Mm.
so yes.
All right. Now, at this point, I'm coming. So at this point, all the time, note that when you are taking something, you take it with a sign in front. So let's do with the 7. I see it's common, right? So let's do with the 7. I have 7 exponent 21. It will be plus 20. You get what I mean? Because
Yeah.
they are multiplying. So 7 exponent 21 plus 20. Yeah. Then the other one will be okay. 1 second. Let me see.
So shouldn't we try and send the division sign first? So
That's what I'm thinking. Okay. 3 exponents. This thing, if you're not careful, you would. If you're not careful, you will not express it properly. Let me see. All of this means divided by 3, sorry, negative 15. I'm rewriting it this way to have a perfect view of that. 3 exponent negative 15 over 2. Yeah, 3 exponents. Oops. Yeah, 3 exponent negative 15 over 2. Yeah, on 2 exponent 5 times 7 exponent 20. Yeah, okay. Let's do with the division part and let's see something. So we would have 3 exponent negative 4 times 7 exponent 21. Yeah, so let's do with the base. That will be 3 exponent negative 15 over 2 times. You reciprocate. Okay. Negative
over
15. So I introduce a multiplication sign, so you reciprocate that to be is divided by it was divided by 2 exponent 5. Okay. So that'll be 1 over Okay. 3 exponent negative 15 on 2. So it's like this. Okay. We are looking at this part. Yeah.
Oh, okay, okay.
Yeah, just that part. And and that's how it looks. 3 exponent negative 15. And 3 exponent negative 15 on 2 divided by what? 2 exponent 5. And usually when you have something like that, we reciprocate it. We turn it out upside down if you want to introduce a multiplication sign. So that would be 3 exponent negative 15 over 2 times 1 over 2 exponent 5. Yeah. Yeah, times 1 over 2 exponent 5. 2 exponent 5. Yeah, just that aspect. Then remember it's times what? 70. 7 exponent 20, sorry. Yeah. Now let's see. 3 exponent negative 4. Let me confirm if you've not omitted anything first before we continue. 1 second. 3 exponent negative 4 times, yeah. We re-express this properly then. Uh, check the denominator for me. That 3, I'm coming. That would be square root of 3 exponent 15. Oh, it's a decimal. It's even a negative number, sorry. Uh, that would be 1 over, okay, 3 exponent, 1 second. Yeah, 1 over 3 exponent. mm, okay, 15 over 2. Yeah, yeah, exponent 15 over 2. It's also in standard form. Mm, 3 square root of 3 exponent 15. What's that? I'm sure it's also in a standard form. Mm, okay, let's see. Okay, so your lesson. That 3 exponent negative 4. Let me see, because I see 3 here. Let me see if something works out for us. That'll be 1 over 3 index 4. Okay. Times 7 exponent 21. That face also can be 1 over 3 exponent 15 on 2. The same 1 over 3, I see. Times 1 on 2 exponent 5. Yeah. Times 7 exponent 20. Okay. I believe you can see your screen. 1 over 3 exponent 4. Uh, can you see your screens at all?
Yes, sir, we can see.
Okay. So I believe you see the bases are the same. So the bases are the same. So it's safe to assume that 1 over 3 throughout. So 1 over 3. So that'll be 1 over 3 index,
Exponent.
index,
Four.
index. That'll be 4 minus 15 on 2. When we are done, we'll check from the calculator to see. Then times, that's 7 also. 21 plus 20. No, they are divided. So
That divided
21,
to one.
21 minus 20 times that will be, yeah, times 1 over, I'm coming on. Yeah. Yeah, times 1 over 2 exponent 5. Yeah. One over 3 exponent 4 minus 15 on 2. 4 minus 15 on 2. That's minus 7 on 2. Hey, are you people following? 7 exponent negative. No, 21 minus 20 is what, 1, eh? So 7 times 1, 1 on, yeah, 1 over 2 exponent 5. Okay. These are just values too. 1 second. 1 on 1 over 2 exponent 5. I believe that'll be 2 exponents. I'm coming. I believe that'll be 2 exponents 5 over 1. Let's check on the calculator. 1 over 2 exponents what? Sorry. 1 over 1 on 2 exponents 5. Yeah, that'll be 2 exponents 5. So times 2 exponents 5, which is 32 or something. I don't know. Yeah, 32. Yeah, so this, okay, so that'll be 1 on, the question says simplify on.
Yeah.
Okay, so,
Really.
okay, so this one will be 32. Okay, um, I'm coming on. That will be 32 times 7. It's evident. So 32 times 7. That will be 224. That will be 224. But can 224 be expressed on a base of 3? 3 times 3 times 3 times. Let me see something. 224. 8 to 1. Okay. Times. No. Hey, are you guys following?
Yeah, yeah.
Okay, we can express
So
it
it
on a
can be
base of
expressed
3. Yeah,
as
we
three.
can't. Then we'll leave this as the final answer. But I'm coming. The index is negative, so I can even change it as um it was originally yeah, we can change it as 3 exponents. That'll be 3 over 1.
Seven
So
over
3
two
exponents 7 over 2. Yeah, because when you
times.
have a number raised to a negative index, it's equal to the reciprocal of the number raised to the same, but you don't mean it. 1 over 3, yeah, 3 over 1 exponent that times 224. Okay, then what happens? Let me see, square root of. So this one becomes square root of. We'll review it, eh? We'll review that.
Okay, sir.
Square root of 3 exponent 7 times 224. We'll review it if we've made any error somewhere. What is 3 exponent 7? And square root of answer. Uh, if you check this, that
Two
would be,
one seven.
yeah, square root of 2 something.
2187.
Yeah, 2187. Yeah, times 224. Uh-huh. So that is square root of 2187. It's the solution is long, Papa.
Long, very
Yeah,
long. So I
27.
was like,
Okay, yeah. So 27 root 3 times 224. At this point, unless we can solve this using set, but I believe at this point I'm coming square root of 224. No. So this, I believe this is the answer. But let's check. Let me use a calculator to check something. 27 root 3 times 224. Let's write this decimal down and see. I'm having 10475.44 something something something. All right, let's check the main question from the calculator
I
to
was
see.
saying that
Say that again.
be
Your
expressed in
your line is
square root
fluctuating.
form.
I didn't get a question. Come again. I'm
I was
pointing.
saying that 224 can't
Mm-hmm.
be form.
Yeah, I will check that, but I want to make sure like we are on the right path. The last part, I believe I can do something about it. But I want to check and see if when I punch the whole question on the calculator, the final answer I'm getting is the same as the last thing I have.
Okay.
Yeah, before I can even proceed. I believe the last part I can do something about that. So 3 exponent negative 1 times 7 exponent 2 over 3 exponent 3 times 7 exponent negative 4 or index 7 over 2. Yeah, divided by the solution is very long. Divided by 3 exponent 3. 3 exponent 3 times 7 exponent negative 5 all over. Is someone also checking or you are just relaxed? That's why I don't like solving
Yes,
assignment
please,
for
I'm
students.
checking. Yes, I'm
Okay.
checking.
Okay.
Mhm.
2 exponent negative 2 times 7 exponent 3. Because when I do it and it's wrong, I can map out and see where the error is coming from. But at the end of the day, I'm just enjoying it alone. I mean, building myself, not you. Okay, when I check, geez, 3 exponent negative 1 times 7
The
exponent
calculator is
2.
giving you one point.
Hmm, yeah, but do it and let me see. When you point there, what did you get? Divided by 3
Yeah,
exponent.
so I couldn't punch this. I punched the first part. Calculator is giving me 1.16 times 10
No, I mean do for
exponent
everything. I
11.
want to know the final result for everything. Negative 5 over.
Okay.
The calculator is okay. Let me see something. I'm getting zero. The full answer is 0.1774. Okay, let's see what part. There is a part I'm confident about, and there is a part I'm not confident about. We come here, let me see. We did to a certain point. 1 second. Mm, I'm checking. No, let's check here. Let me check this from the calculator if that gives the same answer. Oh, let me pause. All right, so after proofreading, when we checked on the calculator, the final answer we get from the main question, which is 0.174, if you map up this area I've taken, this step on the calculator, you get the same thing. So let's take our time to look at from this side to the down. Now,
Okay, so
Biggles, you raise an objection. Let's see, negative 7 over 2 minus 21 over
it was
2.
supposed to be negative 14, but
Mhm.
then whilst you were
Yes,
writing
please.
it, it didn't
Negative
come out
14.
Is
well.
That's
it
what
this
It
I was
side?
became
talking about.
negative
This
4,
side?
and then so come after this 3 exponents negative 7 over 2 minus negative 21 over 2. The next
Mhm.
step.
Yeah, so it will be times 7 exponent
After
7.
solving the exponents, it was supposed to be 3 exponents negative 14.
Oh, okay, I'm coming. And we made it 4.
Yes, but you made it
Negative
four.
4.
That's what
Okay,
I was talking
Mm.
about.
okay. But before then, let me check the other side to if it's okay. Times. Yeah, yeah, times. Yeah, that's positive. Yeah, so times 7 exponent that plus, right? Oh, okay. Yeah, so, when you do 7 over minus 7 over 2 minus 21 over 2 is minus 14.
Mm.
Okay. So times. Be using your calculator to be checking it. You sure the rest
Okay.
is in order?
So we're still going.
Okay, let me use my calculator too. Mm, okay. So 7 plus 14. Yeah, that's correct. Mm, 25 on 2 plus 15 on 2. Yeah, 20. Then let's move on. So that'll be 3 exponent negative 14 times 27 exponent 21. On 3 exponent negative 15 over 2. All over 2 exponent 5 times 1. Okay, let's move on. And 3 exponent. So here changes to 14. Oops. So that'll be 3 exponent negative 14 times 7 exponent 21. Yeah, all over 3 exponent. All right, times 1 over 2 exponent. Yeah, okay. Times 7 exponent 20. All right. Now, Mr. Sarkodie, I'll call you. Okay. Then where else again? Mm, negative 15 over 2 times. All right. Okay. So that will be 1 over 3 exponent 1 over 4. 1 over 14. Yeah. 1 over 3 exponent 14 times that. Okay. 1 over 3 exponent 15 on 2, right? Times 1 over, yeah, times that. Okay. Then we move on. So that'll be 1 over 3. That'll be 14. What's that? 1 over 3. That'll be 14 minus 15 over 2 times 21 minus 20. Yeah. Okay. Now 14. So we have 14 minus 15 on 2. 15 on 2. That's 13 over 2. So this side will be 13 over 2. Mm, all right. Yeah. It's not even minus, it's positive here. It's 13 over 2 times 7. Yeah. Times 2 exponent 5. Yeah, that's true. So now that'll be 1 over, yeah. This side will be 13 over 2. 13 over 2, right? Times, that side is correct, 224. So, that'll be 1 over, so here you'll be having, okay, so let's clean. It's making sense now. Yeah, let's clean. It's making sense now. So if this is the case, that'll be 1 over, I mean, 13 exponent, 13 over 2. That's what it's going to be.
3 exponent 13 over 2.
So 3 exponent 13 over 2, yeah. Times what?
Times
224.
4. Then if you punch it, you get the 0.177.
Okay, I'm coming. Square root of 3 exponent 13. That's a decimal. Okay. And By the way, let's check if the final answer tallies first before we apply any algebraic reasoning. 13 over 2, because we know the final answer from them. Yeah, it's correct. So
It's
zero
correct.
point 0.1. So in fact, this is correct. Okay, so right now at this point, we just apply a little algebraic reasoning and that is it. Uh, it's not even plausible. So I think mm, we should leave it like that. Because 224, I can't write it in multiples of 3. Yeah, you come in, let me multiply 3. You will not get that. 1 over 3. I'm coming. What about square root of 3? Let's leave it like that, okay? So let's leave it like that. It's okay. Because you can't do anything. I've just thought through about that. You can't do anything about that. So there's a final answer. But believe me, that was so long.
Like
I'll
I solved it. I got the correct answer, but then because it was so long, it was more like
You got
I
discouraged.
confused myself ahead.
Yeah,
So I was like,
sorry about
no,
that.
I can't solve this question. It's too long.
So sorry about that. So you saw the technique I used. I mean, we are all not perfect. What just happened? Yeah, we are all not perfect. So, um, as a teacher, what did I do? I went to the start, coded everything on the calculator, the first question on the calculator, and it gave me a fair idea that this is a final answer, right? And of course, we can't leave our answer in decimal. There's a question in indices. It expects us to apply the laws and rules to simplify to the lowest form, right? So, knowing there's a final answer, I just apply indices onto a point it can no longer be solved. So I arrive at this stage. At this stage, when you punch it on the calculator, you get the same decimal, right? But you can't apply any rule again to reduce this. So this becomes a final answer. Yeah, so good for you. We recorded a session, so you can go and play it over and over again to get the concept. Yeah. Any question? And thank you, Big Girls, for drawing my attention to where the flaw was. Any question? Uh, Come and let me zoom for you. It disappeared. Oops. I'm coming. Yeah. All right. So that is it. Any question? I'm afraid this will bring us to the end of the session. Any question? So tomorrow you have a social studies session. See you next in another lecture. I'm gonna end the recording.